In first class you see only a definition of vector quantity. In this class we adding two vectors. That is, we know about the law of triangle addition. If A and B are two vectors of same kind, means both are like vectors. That is, if A is velocity, then B is also a velocity vector. So, and force vector, acceleration vector, electric vector. So such sets of a vector are called same kind, and only addition between the vector is of if they are of same kind. Now, according to triangle's law, if both vector A and B, suppose A is in this sense and B is in this sense, if we are adding vector A and B, that is, if adding a vector B in vector A, then tail of B is started on the head of A. Such vectors are called order vector, or arranging vector A and B in order. That is tail, head. So the resultant, or a sum of these two vectors, is this third side of a triangle, whose one side is vector A, another is vector B, and this is the resultant, and the resultant vector is in reverse order. You see here, if you move, you getting tail, starting from tail, head, tail, head, and if you turn this, first come not head, it is not tail, it is head. So tail, head, tail, head, head, tail. That is, both vectors are in order, and this is out of order from these two vectors, or it is called reverse order. Relatively reverse. These are reverse of this vector, these two vectors in order. If A, B, C is a triangle, then BC is the geometrical length and its magnitude is of physical length of vector A or side BC. So on and so forth. It is also same as all these two vectors. Now, what is the angle between the vectors? If A and B are vectors like it is diverged from a point, or it appears to diverge from a point, then this is called angle between vector A and B, because if we shifting vector A in this way such that like this, then you see this is the point where vector this and this is diverging from a point. In this is called the angle between vector. Or another way, if you shifting B along this, then it converges at a point. You know that this angle or this angle are same. If this angle is theta, then A and B is diverging from here, so angle between this and converging at this point, so angle between this is are same. So theta is the angle between the vector. Now let this is alpha, which is the angle between vector A and A plus B. Okay, that is alpha is the angle between the vector A and the resultant. Here sum is not like an algebraic, it is only symbolical representation of addition of two vectors of the same kind. We are actually knowing the vector A and B. Here the given vector means we know the modulus of A, modulus of B, and the angle between the vector A and B. That is, we know the mod of vector A, we know the mod of vector B, and theta. So we now try to obtain the modulus of vector A plus B in terms of these two vectors. For this, we applying cosine rule. You know, as in trigonometry, I actually lecturing also for mathematics. If you want to the formula or study for mathematics, you see the lecture of mathematics. Now by cosine rule, the cos of the angle between the two sides of a triangle. You are taking a triangle interior angle, cos of pi minus theta equal to, you observe that if you are seeing clearly, these are the sides which makes an angle this pi minus theta. So length of the square plus this square, these two sides, and taking this AB as a square, this sorry for the disturbance, divided by the same side as in linear form BC AC. These are actually called the symmetrical length of vector. This is actually in second quadrant, cosine will be negative in the second quadrant. Suppose this angle is pi minus theta, second quadrant, so minus of cos of theta, square of the length of the side BC plus square of the length of the side AC minus square of the length of AB by 2 of BC into AC. length of BC and length of AC. As you know that the magnitude of the vector A are this way, right, proportional to its geometrical length. Geometrical length means side BC. That is, similarly, it is like this, side AC. And the modulus of A plus B to AB. If you are removing proportionality, BC be constant of modulus of, here we will be using the symbol for simplicity. AC is something constant, suppose C0, B, and AB, A plus B. This constant is same in all the equality. This constant is clearly positive because this is the length positive, this is the modulus, so must be positive. The answer, if you arising a question why not this is be 0, the answer is, if it is 0, then vector A will be undefined, or say in another way BC must be 0. But here you see BC is not 0, AC is not 0 and AB is not 0. So C0 must be positive. Now putting this value in this, we getting minus cos of theta BC, C and this, square the modulus of, square same as here, C0 B square of this, square of this, square of this, square of this. Two of C0, A of B, the C0 square of this. C0 is, because C0 is not 0, so it is cancelled out, taking C0 as a common factor, and it is cancelled from this. So minus of cos of theta 2 of mod of E mod of B mod of it is now writing like this. Clearly this is same as actually we want to find this, so modulus of A plus, it is read as modulus of A plus B and the square of this, that is square of the modulus of vector A plus B is equal to square of the modulus of vector A plus square of the modulus of B minus, it is plus 2 into modulus of A modulus of B and the cosine of the angle between the vector and b. So modulus of must be square of this, and trade we getting the modulus of this is the square root and positive square root because it is modulus, so must be equality whole of this. This is our the modulus. Here only getting a modulus of vector a plus b. Now we trying to find the angle alpha for this. If we knowing about this tan of, so now using sine rule, or if you taking a easy step, drawing a perpendicular on this, so this will be suppose a d, then this length will be in terms of vector b mod of b sine of theta, and if you're taking CD as mod of b cos of theta, this is positive because theta is an acute angle, so cos will be positive. Clearly this is. Now tan of alpha is equal to AD by BD. AD by BD. BD is actually BC plus CD. So BC AD is mod of B sine of theta divided by BC plus CD. BC is equal to mod of A and CD is mod of B cos of theta. So it is mod of A plus B cos of theta. This is actually theta is acute, so this will be positive sum, and this is also so this is the last denominator will be positive. It is greater than modulus of A, means BD is greater than BC. You see here BC has the length, physical length equal to mod of A, and CD has a length mod of B cos theta. Because this term is dimensionless, so CD has same dimension as B, or you know that A and B are of same dimension, so this is a dimension same as vector B. Tan of alpha must be dimensionless, so this is dimensionless because of this is a dimensionless. This is also a dimension as same A or B, so it has a dimension of same as vector B, and here is also as vector B, because you know these two vectors are of same dimensions, so this ratio is dimensionless. It must be. In this, due to time being, Now the examples solved on this result, modulus of this in next lecture or part third lecture. Thank you.